Very good afternoon. Today, I'm going to discuss the topic pointer to a pointer variable. We already discussed about the topic pointer and the pointer variable, how can be used to access the data members of an array, of an 1D array, of an 2D array. That part we already discussed with you. Today, our discussion topic is pointer to pointer variable. What is pointer variable? That we already know. Pointer variable is a variable which can store the address of another variable. And the declaration of pointer variable is like this: int star ptr. The meaning of this int star ptr is ptr is a pointer variable which can store the address of another integer variable. And I already explained this example in my previous lecture, where I considering a variable a, the initial value of a is 5, and taking a pointer variable that is ptr, and ptr is storing the address of a. So assuming the address of ptr is 65520, so when I am printing the value of ampersand a, so that must give you 65520. If you print the value of ptr, that also gives you 65520. If you print a, that will give you 5. If you print star ptr, that will also give you 5. So this much we have already discussed. Now we are coming to discuss. We are coming to discuss about the topic pointer to pointer. So first, try to understand what this means. Then I will explain this concept by using a program. Look here, I have considering a variable int start star ptr, int start ptr, and another variable star ptr1. So both this ptr and ptr1 is a pointer variable. Hopefully you don't have any confusion regarding this, because both are declared with indirection operator. ptr and ptr1 both are pointer variables. It is very much true. And a is a normal variable. Fine. Initial value of a is 5. Now, what is this ptr1? It's a pointer variable. It consists one single indirection operator. So that means ptr1 can store the address of another normal variable. ptr1 can store the address of another normal variable. Try to understand. So ptr1 equal to ampersand a. What about ptr? ptr is a pointer. The meaning of this star ptr is a pointer variable which is storing the address of another pointer variable. If instead of 2 star, if there is a 3 star, if you declare a pointer variable like this, int start ptr, what it means? ptr is a pointer variable which can store the address of another pointer to a pointer variable. Try to understand. How we can explain this star ptr? The explanation word is ptr is a pointer variable. Definitely it's a pointer variable, but it is not storing the address of another normal variable. Instead of that, I'm telling PTR is such a type of a pointer variable which is basically storing the address of another pointer variable. Try to understand by using this diagram. So A is a normal variable. Value of A is 5. Address of A is 65520 according to our consideration. This address allocation is done by completely operating system and compiler. So this is not in our hand. What will be the value of the address of that variable? We assume the address of the variable is 65520. Nice. What is PTR1? That we already introduced in the previous lecture. PTR1 is a normal pointer variable which can store the address of another integer variable, because I have declared PTR1 as int star PTR1. So that's why I have taken PTR1 is a pointer variable which is storing the address of variable A. The address of variable A is 65520. That's why I have written the value of PTR1 as 65520. But thing is that PTR1 has also its own address, because PTR1 is a variable. Though it's a pointer type variable, so it's a variable. And we all know each and every variable must have an address, right? So what is the address of PTR1? I assume the address of PTR1 is 65504. Now coming to explain about the variable PTR, because I told earlier that PTR is a pointer variable which can store the address of another pointer variable, not another normal variable. That's because I declared I declared PTR, not only star PTR, I declared PTR as int start star PTR. So as you declared is int start star PTR, so that means PTR is a pointer variable which is storing the address of another address of pointer variable, not address of normal variable. So that's why it is storing the address of PTR1. It is storing the address of PTR1. That's why the value of PTR is 65504, which is basically the address of PTR1. And the address of PTR is 65502. We are not concerned about the address of PTR because it is not required in these cases. If you consider one more pointer variable, that is int start star PTR 2. So now PTR2 is such type of pointer variable which can store the address of another pointer to pointer variable. So PTR2, the value of PTR2 must be 65502. Try to understand. It is just like a chain. And in the first class, when the lecture going on, I mentioned one line in the PowerPoint slide that the ampersand and indirection operator, that means star, and the address of operator basically complements each other. Look how it complements each other. I'm going to explain once again. Coming to the coding part. PTR1 equal to ampersand A. Very nice. Because PTR1 is ampersand A, that is 65520. Very nice. In the very next line, what I've written, PTR equal to ampersand PTR1. So that means PTR is such a type of pointer variable which is storing the address of another pointer variable. So which pointer variable I am talking about? I am talking about a pointer variable named PTR1. So PTR is such a type of pointer variable which is storing the address of another pointer variable PTR1 here in this case. So what is the address of PTR1? The address of PTR1 is 65504, right? The value of PTR1 is 65520, but the address of PTR1 is 65504. So the PTR equal to ampersand of PTR1 is basically showing this line, this diagram. The value of PTR is 65504, and definitely the address of PTR that we are not concerned about for this program, it is 65502. Forget about this because we are not concerned about 65502 in this current program. So now I am going to split up this start PTR. Look, what is the meaning of PTR? It's ampersand PTR1, right? We can replace this PTR as ampersand PTR1. So what is ampersand PTR1? How much it is? It is ampersand PTR1, address of PTR1, that is 65504. Are you agree? Hopefully. Then I'm putting an indirection operator out of this, right? I'm putting an indirection operator out of this. So what is the meaning of star 65504? Value at address 65504. Hopefully you agree with me. Value at address 65504. If it is the value of address 65504, how much it is? 65520. 65520. Fine. Now justify the line. Indirection operator and address of operator complements each other. Look, if you complement, if these two are complements, star and ampersand, if two are cancelled out by using one with another, star and ampersand you just cross because they are complementing each other. So if they complement, that means 0, 1 becomes, it complements, it cuts each other. So what left? Only PTR1. What is PTR1? That is 65520. So that's why the line mentioned over there. Indirection operator and ampersand operator basically complements each other. They basically cut each other. So ultimately, as per our basic knowledge, as per our basic concept, yes, we agree with that line. And then what is the meaning of this star 65520? Because 65504 we got. What is the meaning of this star 65504? That is 65520. Yes, fine. And what is the meaning of star 65520? Value at address 65520. How much it is? It is 5. So what we are doing, we are accessing the variable 5, the variable A, not 5. We are accessing the variable A by using a variable which is nothing but a pointer to pointer. Pointer to pointer, as a conclusion, what we can say, pointer to pointer is such a type of variable where a variable is not storing the address of another normal variable. No, it is storing the address of another pointer type variable. Fine. We are return back to our programming section where we can explain this practically. Just a minute. Fine. So I'm first saving this program. See source file. Say naming it FN7. Fine. Trying to write a program. So what I declared int, say star p1 comma star p comma a, and the value of a is 5. Fine. And the very next line, what I've read, p equal to ampersand a. and P1 equal to ampersand of P. So print one after another. Printf ampersand, first of all, a equal to slash n, a equal to %d, comma a. Very next line, I am printing the value of ampersand a. I hope you agree with me that the value of ampersand a must be same with the value of p, because I assigned p equal to ampersand a. That must be same with p. I have assigned the value of this is p equal to ampersand. So both these two lines will give you the same result. Next line, I print the value of T1. What it is actually? I'm going to print the value of P1. Before going to print the value of P1, I'm going to print the value of ampersand P, because I already assigned the value. I already assigned the value P1 to ampersand P. Right? So P1 is a pointer to pointer variable. Try to understand. P1 is a pointer to pointer variable. Why? Because P1 is such a type of pointer variable which is basically storing the address of another pointer variable P. And P is a pointer variable, is a normal pointer variable which is storing the address of what? Address of another normal variable, normal integer variable here, that is A. So execute up to this much. Then I will coming to the latter part. Let me share my screen. Look, A equal to 5. The second line is basically address of A. It's a typographical mistake. It is address of A, that is 6487612. Third line is P. It's genuine address of P. What is, only P, which is equivalent to address of A. So that's why both these two lines are giving the same result. Next line, I'm printing the value of address of P, which is 6487616, and that is equal to the value of P1, 6487616. Both these two values must be same. Hopefully this much is clear. Coming back to the program again. Fine. So instead of only A, it should be ampersand. Now, if I print star P1, what it will give? Star P1. Try to remember the diagram. Star P1. What is P1 actually? P1 equal to address of P. P1 is nothing but address of P. So you put the address of P. You put the address of P over there. So when you put the address of P over there, address of P over there, what is basically address of P? A pointer variable. Just a minute. Okay. So coming back to the program. So we are going to print the value of star P1. I asked what will be the value of this star P1. That is our question. So basically star P1, if you replace P1, what it will be? It will be ampersand of P. Ampersand of P. That means address of P. Address of P I am talking about. Value at address of P. What it will be? What it will be? Value at address of P. That will be definitely address of A. Nothing else. Value at address of P. That will definitely the address of A. Value at address of P. That will be the definitely address of A. So let me check it. Execute the program. Look, value of star P1 is 64876112. Once again, I am going to explain. A equal to 5, ampersand A equal to this much. Hopefully two screen is visible to you, both the screens. One is output, another one is the programming itself. So try to understand. A is equal to 5. Fine. Ampersand of A, that is assigned by West, the value of A is 64876112. Fine. What is the value of P? Definitely P is equal to ampersand O, so the value of P and ampersand A both are same. Agreed. Ampersand P, that is also assigned by the West and compiler. It is the new value 6487616, and that value is assigned to P1 because P1 is such a type of pointer which is basically pointing to another pointer variable. So that's why the value of P1 and ampersand P both are same. Now we are going to print star P1. So if you write it down in your copy, star P1, instead of P1, what you can write? Ampersand P, right? In place of P1, you can write ampersand P. So it looks like ultimately the second step will be star of ampersand within bracket ampersand P. How much ampersand P is? 6487616. That is ampersand P. Keep it in mind. Star of, now my question is, star of 6487616. How much it will be? What is the meaning of this question? The meaning of this question is, I want to ask the value at the address 6487616. The value at the 6487616 is the 6487612, because that is the value of P. That is the value of P. Star P1 means the value of P. What is value of P? Value of P is nothing but address of A. And that's why this star P1 gives you the value 6487612. Hopefully this much is clear. So now if I put, again, going back to the program. Now if we put the value, if I write the value printf, so better to say, so this value definitely same with the value of p, not star p, right? Star p1 is basically ampersand p, so definitely that is the star p1 I am talking about. So that means it is the value of p. So printf star p1, if I write value of p, that means only star p, will get the same result again. Let me check. No, sorry, not star p, only p, value of p I'm talking about. Look, let me share the screen. Yes, both are giving you the same result. First one I have printed by using star p1, second one I have printed by value only p. Both will give you the same result. Okay, back to the programming. Now, so if we put the value of printf, sorry, make it copy and paste, fine, start star p1, what it is, it will definitely the value d start star p1 I have printed. Instead of start star p1, how we can modify it? Look, start star p1 can be modified as, what p1 means? It is ampersand of p. It is ampersand of p. P1 can be replaced in this way. It is ampersand of p. So instead of p1, if we write ampersand of p, then also it will give us the same result. Fine. And what is the meaning of this? Again, I am splitting it more. Star of star of ampersand p. So if we write this star p, that will also give you the same result. That is value of a. We have started with the value of a. Again, we have returned with value of a. But a is accessing, a can be accessed by using pointer p1, by using pointer p, both. And last three line, 15, 16, 17 will give you the same result. Let me check once. Look. Look, last three line, last three output lines. Start star p1, that is 5. Instead of p1, if I put ampersand p, that means value at address of p. Star of this 5, and obviously star of p is also 5. So in this manner, using the same manner, we can put n number of stars before a pointer variable. So no need to worry if you have seen this number of stars is given, because it is very simple concept. It is very simple concept. Just like this, I'm again putting one more pointer variable in the program. Just in the same explanation, I can put it. Using the same explanation, we can use another pointer variable. Say it is star 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 p2, right? Comma. Better to say, take it first, star 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 p2. So what it is actually? What the p2 is? P2 is nothing but a pointer variable which is storing the address of another pointer to a pointer variable. Try to understand. P2 is a pointer variable which is storing the address of a pointer to a pointer to a pointer variable. Fine. Just check it. If you print the address of P1, let me check. The address of P1 fine. If you check the address of P1, what it will give? Address of not P, it is address of P1. And that value must be same with value P2. Must be same with value P2. Let me check it. Yes. New share. Look, up to star 5 we have seen. Ampersand of P1, that is 6487616. What P1 stores? What P1 stores? Try to understand what P1 stores. Address of P. Address of P. What is actually your address of P? Your address of P is, look, 6487608. That is the value of P1, right? That is the value of P1. Now we were storing the address of P1 inside address of P2. So my next question, what will be the value of star P2? What is the value of star P2? Tell me what is the value of star P2? P2 is the pointer variable which is storing the address of P1. What is that value? 6487616. In 6487616, how much value is stored? How much value is stored? Value of P1. How much value it is? 6487608. So if you print the value of star P2, you will get 6487608. Let me check. Very next line, I will print, try to understand, I will print the value of star P2. Look how much this value will give. Value of star P2. Definitely it's an address. Look, star of P2 is 6487608. Fine. What is star P2? If your star P2 is 6487608, that means at address 6487608. How much value it is stored over there? That is the value of P actually, 6487604. So put it, check it, better to say. If we print the value of star P2, right? And the very next line I'm going to print star P2, and definitely it is the value of A. So that's why I've put it %D instead of %U. If you put it %U here, then also the value gets printed, because I have considered as plus value, plus how much, plus 5 or plus 3, plus 5. So %U also works here. So let me check final output. Look, once again I am repeating. What is P2? It is address of P1, right? What is P2? It is address of P1. What is the value of address of P1? Look, it is already gets printed. Address of P1. That is P1. That is address of P1. That is 6487616. That is the value of P2. Fine. This is address of P1. And this is P2. Hopefully this much is clear. So what about star P2? What about star P2? Star P2 means value at address 6487616. Fine. What is the meaning of this address 6487616? This is nothing but address of P1. So what P1 stores? P1 stores address of P. Fine. How much it is address of P? 6487608. So the value of 6487616 is 6487608. Hopefully this much is clear. That is the meaning of star P2. Fine. So if you put star before this, before 6487608, so value at 6487608, how much it is? That is actually the value of P, because P1 is storing the address of P, that is 6487604. So that's why this is giving star P2 is giving 6487604. Hopefully this much is clear. Now, if you put one more star before this, so value at 6487604. What is this? Address of A. 6487604 is nothing but the address of A. So value at 6487604 is definitely 5. So that's why when I'm printing star P2, that gives us 5. So in this way, we can add 3 star, 4 star, 5 star, 6 star. It will not be a problem for us if this concept is clear to you. I hope you understand what is the meaning of pointer to a pointer. It's a very basic fundamental concept, but it is very much required to access elements different times in different scenario. Okay. Next, we'll move to another part of my lecture, today's lecture, that is selection sort. Today, we try to implement one sorting algorithm using pointer. So before I choose selection sort to do this, so before implementing the sorting in program, let me briefly explain how selection sort algorithm works. So try to understand this first. Let me share the screen once again. So what selection sort is, how it works. Firstly, I'm giving you a brief idea, then I'm coming back to an example along with the algorithm. Consider an array. Say your array have 5 elements or 6 elements. Say 6 elements you have. Listen carefully. You're considering an array having 6 elements. So your index lies between 0 to 5. 0, 1, 2, 3, 4, 5. What you are trying to do? Implementing selection sort. Elements are unsorted. You are trying to implementing selection sort over here to get a result of ascending order of those elements. Fine. So you selected the first index 0. Fine. Next step is you are finding the minimum elements. Which elements you have selected? Index 0. Remember it. You have selected index 0. You finding, rather you are searching the minimum element from index 0 to index n minus 1. What you have done? You have finding a minimum element from index 0 to index n minus 1. Say you got an element at position pos, say it is pos, which is minimum from index 0 to n minus 1. Your n minus 1 is 5 because you have considered 6 elements. So you choose a minimum, you find the minimum elements and say your minimum element as index pos. The next step is you have to swap the element of ARRI, your case it is 0 now. ARRI means the elements which you have selected. You have selected index 0. Next step is you are finding the minimum elements from ARRI to n minus 1. That is element from 0 to n minus 1, 0 to 5. And you got the minimum element at index pos. Next step is you have to swap the element ARR pos with ARRI. Iterate the loop. So now when you iterating your loop for the next time, for the second iteration, so your selected index, that means your I becomes how, what, 1. Previously it was 0, now it becomes 1. What is the next step? Your next step is you have to find the minimum from, not from 0 to n minus 1. Now you have to find the minimum from 1 to n minus 1. Again, it returns you the minimum value index, the index of the minimum value. So it is again pause. Third step is you have to swap with ARRI, that means your selected index, that is 1, with ARR pause. Iterate the loop. Your third iteration value, now your I value is 2. What is the next step? Again, you have to find minimum from ARR 2 to n minus 1. Again, it returns the index of minimum value, say it is pause, and you have to swap with ARR I with ARR pause. So what you are doing actually, try to understand. Particularly in each and every iteration, you have selected an element, that is I equal to 0, I equal to 1, I equal to 2, I equal to 3. In this way, you are finding the minimum elements from 0 to n minus 1. When you have selected I equal to 0, you have to find the minimum from 0 to n minus 1. And what you were doing? You were swapping with the minimum value with ARRI. So what is the consequence of this step? You have finalized the value at index 0. Because when you are finding minimum from 0 to n minus 1, that means you are finding the lowest value of the array. And you have, when you are swapping, that means you are putting the lowest value at index 0. In the second iteration, when you have selected index 1, what you will do actually? You are finding the minimum from index 1 to index n minus 1. And that is the second minimum element of your array. Try to understand. And when you are swapping, you are putting your second minimum element in the second index. That means index 1. Second minimum element in the second index. In this way, each and every element, you are selecting each and every position, and you are finalizing the value of each and every index. So in this way, you have finalized the value 0, index 1, index 2, index 3, index 4, index 5, index n minus 2, up to index n minus 2. So when you finalize the value up to index n minus 2, your array indexes lies between 0 to n minus 1. Your array index lies between 0 to n minus 1, right? Now, what you are doing in each and every iteration, you have finalized the value of each and every index from 0 to n minus 2. That means automatically the value at index n minus 1 gets finalized. So you have to iterate an outer loop from 0 to n minus 1. Look, the things that I have just discussed over here, it is written in a form of an algorithm. For I equal to 0 to n minus 2, find the minimum value in the list from ARR I to n minus 1. Say the minimum element at index pos. Swap it with ARR I with ARR pos. And repeat the steps above for the remainder of the list. So this is the brief formation of this algorithm that I just mentioned before coming to this part. And I'm showing you an example. This is your array consisting 10 elements. First element you have selected 26. From 26 to 77, which one is the smallest? 17 is the smallest. So you have swapped 26 with 17. Fine. Next you have selected 33 and you have find the minimum between 33 to 77. How much is the minimum? It is 26. Swap 26 and 33. Look. Next you have selected the element 43 and you are finding the minimum element from 43 to 77. The minimum element from 43 to 77 is 33 and you have swapped 33 with 43. Now your output is this. Next you have selected element is 100. Fine. You have to find minimum 100 to 77. Which one is minimum? 43 is the minimum. Swap 100 with 43. Fine. Next you have selected element is 46. You have to find minimum 46 to 77. Which one is minimum? 46 itself. So when you are making swap, it swap with itself. So 46 remains 46 plus. Now next element is 88. Find the minimum between 88 and 77. Which one is minimum? It is 52. Swap it with 52. 88, 52. Again, you have to select the element 88 because you are moving the index. You are not changing the value. We are moving the index. So again, you have to choose 88. Find the minimum 88, 77 up to 77. Which one is the minimum? 53 is minimum. So swap it between 53 and 88. So look, next selected element is 100. Next selected element is 100. You have to find the minimum between 100 and 77. This range. So which one is minimum? 77. Swap it with 77. Next selected element is 88. Fine. Next selected element is 88. Find the minimum between 88 from 88 to 100. This range. How much is minimum? The minimum element is 88 itself. So no need to swap and no need to select 100 also. Because when you finalize the value from 0 to n minus 1, sorry, n minus 2, automatically the value at index n minus 1 gets finalized. So this is the brief introduction of the algorithm of selection sort. In the next step, we will implement this selection sort in a program. Okay, so we are trying to implement the selection sort in program. Try to understand. Very simple. Int. So I'm declaring an array of size 10 and ij. So taking the number of elements from the user. Storing it inside the variable n. So scanf %d %n. Nice. Taking input for the array elements I equal to 0 to I less than n I plus plus scanf %d ampersand of ARR I. Fine. So if you print the value, check it. Array elements. Same loop of iterate. I'm writing the same code over here. Instead of print scanf, just make it printf. Remove ampersand. Nice. Now I am entering into the selection sort algorithm part. For I equal to 0 to I less than n minus 1, because I have to iterate the outer loop up to n minus 2. That's why I have considered up to less than n minus 1. What is the next step? Say I'm selecting the element, and I'm storing it inside the variable main, because ith element I have selected, ith index element I have selected, and I have to find the minimum from where to where, from ARR I to n minus 1, right? So definitely we already implemented the algorithm of finding minimum element from an array. First element I need to consider as minimum. So that's why ith element I have to consider as minimum, and comparing the other elements, say j equal to I to I less than n, because I have to finding the minimum from I to n minus 1. So I to n minus 1, j plus plus. It is j, not n. I. J less than n, j plus plus. Inside this, what I have to write? If mean is less than, is greater than ARR of j, right? Then what you have to do? What do you have to do? You have to update mean. You have to update mean, and at the same time you have to select the pause. You have to update mean with ARRJ, right? And at the same time you have to update your pause also. Pause equal to j. Nice. So after coming out, this is the loop where you actually finding minimum from I to n minus 1. This is the code. You are finding the minimum from I to n minus 1. So next step, you have to swap with ARRI and ARR pause. So temp equal to ARRI, fine. ARRI equal to ARR pause, nice, and ARR pause equal to temp. So considering one more variable to declare it, so it is temp. Fine. So then done, just print it, the same thing, make it copy and paste over here. Array elements after selection sort. So give a slash n over here. Give a slash n over here. Give a slash n over here. that you can get a good looking output. Fine, this will print, then after this gets printed. Fine, fine. Let me execute. Semicolon. Just a minute. Sorry, forget to give a semicolon. Same error here also. Pause I haven't declared, so giving an error. Fine. So hopefully now it will work fine. Yes, it is working fine. Enter the number of elements: 5, 55, 44, 33, 22, 11. No, it is not giving the correct output. It is not giving the correct output. Somewhere I have done some mistake. Let me check. So now the program works fine. Forget by mistake give a semicolon after this if statement. That's why it's giving a problem. So if I execute the program, number of element is 5. Sorry, 5, 55, 44, 33, 22, 11. So now it gives us the sorted output: 11, 22, 33, 44, and 55. So I hope this much is clear to you. Now I'm trying to convert this same program, rather I'm trying to do the same program using pointer. I'm introducing pointer over here. So it's very simple. Considering a pointer variable start p, say ptr is my pointer variable, right? So what I can write, ptr equal to arr. Why? Because we know what is the meaning of this ptr. We know what is the meaning of this arr. The arr is basically storing the base address of an array, right? So that means ampersand ARR 0. The equivalent line is ptr equal to ampersand ARR 0. Both these two lines are same. Okay? When I am taking input, I will not write ARR, ampersand ARR I. What I will write? PTR plus I. Are you agree? PTR is the base address. When I equal to 0, that means address of the first element, index 0, plus 1, address of the index 1, plus 2, address of the index 2. So that's why no need to give the ampersand over here, because PTR itself is address. When I'm going to print, instead of ARR I, what I will write? Star of PTR plus I. Are you agree? Hopefully. So this much is over. Taking input using pointer and printed the input elements. Next, instead of ARR I, what I will write? This is value. So PTR plus I. Very simple. PTR plus I. Instead of ARR J, what will write? Star of PTR plus J. So this will be star of PTR plus J. Was equal to J. Temp equal to star of PTR plus I. Very nice. Then star of PTR plus I star of PTR plus pause and star of PTR plus pause equal to 10. Nice. Instead of what we have done? We have done PTR equal to ARR. That means ARR is the base address of the array and that I stored inside PTR. So actually PTR and ARR will behave like the same instance. Will behave like a same instance. What PTR is, that is ARR also. So now when I'm going to print, instead of PTR plus I, I'm writing star of ARR plus I. I hope you all have gone through our previous lecture. Otherwise, you cannot map this, because in the previous lecture I discussed how pointer variable can be used to access the 1DR elements. Next, we discuss accessing the 2D array elements using pointer variable. So here I are just replacing the array elements using pointer. We are accessing the array elements using pointer instead of just normal using. Fine. And in our program, the ARR and PTR are the same thing. So that's why wherever I am writing PTR plus I, that can be replaced as ARR plus I. Because ARR is the base address of an array and I am assigning the same address to PTR. So each and every time when I am writing PTR plus I, that means PTR plus I into size of here data type is int, that much amount of byte it moves to accessing the next element. That part I already discussed with you in the earlier lecture. So compile and run. Number of elements 5, 55, 44, 33, 22, 11. Look, it is working fine. So selection sort done using pointer. Very nice. Then our next attempt, trying to convert it in a function. We are doing selection sort using function and pointer. So giving the name of function is cell sort. Fine. First I am passing a pointer, and second I will pass a normal integer, because first element is my array and second element is my what? The number of elements in an array. So what I will do, void cell sort I'm giving this name as int star ptr so that change will be minimized, and here number of element is say n. Fine, because this n and that n is different. Under main, the n that I have declared is not same with this. Fine, what I am doing here, look, I'm just omitting this line here because I have to use the concept call by reference in this case. So instead of ptr, I am taking arr plus n. Same thing, because arr is basically pointing the what? The base address of the array. This entire part will move to the function. Next, I will modify accordingly. The function is returning void. So I'm just moving this part to the function. Next, after taking input, I'm calling the function. The name of my function is cell sort. What is the array name? It is arr. That will be a pointer that will replace this ptr. Arr is basically ampersand of arr0, and n is remain same over here. This n and that n is not same. That I discussed. That is also I discussed earlier. This n is local to main, and this n is local to main, and this n is local to cell sort. Fine, but it will be copied to this n. This n value will be copied to this n. Nice. Declare the some local variables int I, j, mean, pause, temp. This much are required. So remove this element from here. Ni is required here because n is the number of element, I is the required for loop iteration, and the cell sort is called ij mean pause declared ptr plus I. Star arr will not work over here because it is accessed by the element ptr. Whatever ptr is, so after calling the cell sort, if you print the arr, printf %d star of arr plus I, definitely will get the same result. Why? Because I have passed the base address of an array in ptr, and that means this arr address and the ptr address is same, implementing the concept of call by address. Whatever we have done inside this ptr, that is actually we are doing inside arr, because both ptr and arr is pointing to the same address. So that's why when I'm going to print the value of arr after calling the cell sort function, definitely this is from main. Write it down. This is from function main. After execution of this printf, again I am trying to print the elements of array arr. So print elements from main function so that I can understand this printing is coming from main function, is done by from main function. So I'm printing the array elements from main. So then also I got the sorted result because I have done this sorting by concept of using call by address, not the call by value, right? So let me check whether it is executing fine or not. No, some semicolon mistake is there. Yes, temp undeclared before printf, line number 19. Line number 19, hopefully this is the error, semicolon error. Yes, the output screen is showing. Let me check whether it is giving the output, correct output. I'm not sharing the output screen with you. Fine. 5, 55, 44, 33, 22, 11. Look, this is the array elements after selection sort. This element gets printed from function cell short, and this element gets printed from function main. It's because we are implementing the concept called by reference. We have passed the address of an array to the function, and the modifications that is done by the using pointer ptr is basically modifications done by uh, the address, done in the address where ARR points. So because both are the same, ARR and PTR basically point the same address. So in function we have done some modifications by using pointer PTR. So definitely it reflects to the address ARR because both are points to the same address. That's why when I printed the array elements after calling the function self sort, then also it gives us the sorted results, element 22, 33, 44, 55. So I hope the selection sort is clear to you. At the same time, we have done the selection sort by normally using array concept. Then we have done the selection sort by using pointer concept. Then we have done the selection sort by using function and pointer both. So hopefully this is clear to you. Now you try it your own. The rest of the two sorting that we already discussed with you, that is bubble sort and insertion sort, using pointer and using function. Try it your own. If you have any confusion, you may ask. Otherwise, today I am concluding my lecture. Thank you. Thanks for your patience.